Question 1. So 5p take away 3p, well at that point we've got 2p. 2p add 1p gives us 3p. Now m cubed plus n cubed, well we've just got two lots of m cubed. Now with this, with part C, just be careful, so just make sure you pick up the sign, the appropriate sign. So let's just gather up our normal numbers, so that's just the 10. Now gathering up the C's, we've got a plus 3c and a minus 7c. So 3c take away 7c is minus 4c. Then gathering up the D's, plus 5d plus d just gives us 60. Question 2. Write 56.78 correct to one significant figure. Now with one significant figure, we're only allowed one digit which is not a naught, so just the one digit. So we look at our first digit here. This will be our single digit. Do we stick with the 5 or do we round up to a 6? Well, looking at the next digit, that's 5 or above, so we round this up to give us 60. And when you think about it, we can see that 56.78 is clearly closer to 60 than 50. Those were the two options we were choosing between. Question 3. So part A, what is the most popular type of transport used by the boys? Well, the boys are those shaded in the grey, so look for the tallest bar, which is shaded in grey. It's clearly this bar here, so that is with a total of 9. What is going on here? What are the boys doing? Well, they are walking. So the most popular type of transport is walking. Now for part B, we're told that 7 girls walk to school, so we go to the walk part of the diagram. Girls is going to be just with the lines going diagonally, so we just have to make sure we pop in a column which is 7 high. Use a ruler, please. Now then we're asked, more of the students get to school by car than by bus. How many more? So let's go and add up all our car figures. Okay, so how many so for the car figures, so we've got 5 add 9, so that's 14 children in total go by to school by car. Now by bus, so that's 6 boys and 4 girls, so that's 10 in total. So clearly 14 go by car, 10 by bus. So how many more go by car? Well, that's 4 more. Now we're told the number of students in year 9 is the same as the number of students in year 6, or year 5 is the same as the number of students in year 6. What is the total number of students in both years 5 and 6? So let's go and work out the total number of students in year 6 by adding up all of these bars. So that's 5, add 9, add 6, add 4, add 9, add 7, add 4, add 1, add 2, and 1. Now that's 48. So we've got 48 students in year 6. We've got the same number in year 5. That's another 48. So total number of students in year 5 and 6, 48 at 48, that's 96. Question 4. So write these fractions in order of size, starting with the smallest fraction. So you can either go down the route of finding equivalent fractions. Okay, so we can see with these denominators that they're all factors of 30, so they all go into 30. So we can choose to make each of these 4 fractions something over 30. So if we do that, so with this first fraction here, how do we turn that 5 into 30? We multiply it by 6. So times top and bottom by 6, we get 12 over 30. Obviously 11 over 30 stays as it is. With this third fraction, a half is 15 over 30, times in top and bottom by 15. And 7 over 15, we're times in top and bottom by 2. We can then easily compare the numerators, the top numbers. We go 11, 12, 14, 15. So that's 11 over 30, then 2/5, then 7/15, and then a half. Now, given this is a calculator paper, alternatively, you could just turn all of these into decimals and then just compare them. So just do 2 divided by 5 on your calculator, or use the fractions button, that one third down on the left, and just change each of these into a decimal and just compare those. Question 5. So write down one thing that is wrong with the tally chart. Well, we can see on Monday that it should be 5 add 5 add 3. That should be 13, not 12. Okay. Now for part B, write down one thing that is wrong with this pictogram. Well, you've got a choice of two things. He's made a mistake for both Tuesday and Wednesday. You can see on Tuesday that as each of these shapes like this represents 3, that he's only got 15 CDs being represented, where he would needed 18. Okay, so he needed to put in an extra circle with a line through it. Or secondly, we can go and say that this just can't be possible. A half a circle will be half of 3. That would be 1.5 CDs. So 3 add 6 add 1.5 is 7.5, which is clearly not the right fraction. You can't have half a CD. He needed to represent 8, not 7.5. So question 6. So we've got 495 coins in total. 124 of them are 50p's. Now we're told a third of them are £1 coins. So let's work out how many £1 coins we've got. So that's a third of 495. So do 495 divided by 3 and we've got 165 £1 coins. So we've got 124 50p's, 165 £1 coins, so the rest are 20p coins. So how do we work out how many 20p coins we've got? Well, 495 coins in total, take away the number of £1 coins, take away the number of 50p coins, that means we've got 206 20p's. So now we've got to work out the total value of these coins. Well, we've got 165 £1 coins, so that's obviously 165 times £1. We've got 124 50p's, 124 times 0.5 is £62, and we've got 206 20p's. So that's 206 times 0.2. Remember that 20p is 0.2 of a pound. That gives us £41.20. Add these three subtotals up and we get £268.20. Question 7. Well, we know that probabilities have to add up to a whole, a 1. So if the probability that a new fridge has a fault is 0.015, the probability that it does not have a fault is 1 take away this number. And 1 take away 0.015 is 0.985. Question 8. So write down in the list, from the numbers in the list, write down a square number. Well, 25 is a square number because 5 times 5 equals 25. Now, from the numbers in the list, write down a number that is both a multiple of 4 and 6. Well, 24 is 4 6s are 24. So 24 is both in the 4 times table and in the 6 times table. Now, part C, write down all the prime numbers in the list. Now, remember, a prime number is a number that has exactly 2 factors. So 21 is not a prime number because you can get, apart from 1 and 21, you can have 3 and 7. 22 isn't because you've got 2 times 11. 23 is a prime number because the only way you can get 23 is by 1 times 23. 24 isn't for this reason. 25 isn't. 26 isn't. 27 isn't. 28 isn't. And 29 is. The only way you can get 29 is 1 times 29.
I think it would be alright to...
Question 9. Well, we know the angles about a point add up to 360 degrees. So all the way around the circle is 360. And of course this bit here is a right angle, that's 90 degrees. So what we do know is that the rest of the circle, so the 2x plus the 3x, that added together equals 360 take away 90. So 3x and 2x is 5x, which is 270. Divide both sides by 5. We get x equaling 270 divided by 5, which is 54 degrees. Question 10. So let's have a look at the letters to send option. So pack of 25 envelopes. Well, we need 150 envelopes. 150 divided by 25 means we need 6 packs. Each pack is £3.49, so 6 times £3.49 is £20.94. So that's how much it costs from letters to send. Now from Stationery World, 30 envelopes. Okay, we get buy 2 packs, we get 1 pack 3. So we're getting 30 envelopes. okay, we're getting 30 envelopes when we buy 2 packs. So because we're only having to pay for 2, so 30 envelopes is costing us 2 lots of £2.10, which is £4.20. Now we need 150 envelopes, so if we divide that by 30, we need to buy 5 lots of envelopes at £4.20 each time. 5 times £4.20 is £21, so we can see that letters to send is just a little bit cheaper. Question 11. So part A, change 74 centimetres to inches. So look, using our conversion graph, if we go and find 74 centimetres, so just be careful with the grid, make sure you go up the appropriate number of baby squares, with each square being 2. So find 74, go along a straight line, hit the line, the black line, go down and take a reading, and we're getting 29, because on this scale down here each baby square represents 1, whereas over on this scale, the centimetre scale, each baby square represented 2. So the answer is 29 for part A. Now for part B, Daniel is 6 feet 3 inches, so it would make sense to transfer this into inches. 1 foot is 12 inches, so 6 feet is 6 lots of 12, which is 72. And add on the 3 inches to give us 75 inches in total. Now clearly our graph doesn't allow us to go up 75 inches, we just don't have it on the graph. So what we could do, perhaps we could go up 25 inches, which is a third of 75. So if we go up 25 inches, we can see that that's about 63 centimetres. So if 25 inches is 63 centimetres, 75 inches will be how many centimetres? Well, it's 3 times as big. 25 times 3 is 75. Now 63 times 3 is 189 centimetres. Now the mark scheme allowed for some tolerance, so any answer between 186 and 195 was allowed. Question 12. So obviously we're just going to pop this straight into our calculator. Please do take advantage of the fractions button looking like this, which is normally the third one down on the left on most calculators. So obviously on the top square, just go and open up your square root and put the 13.4 minus 1.5 into the top square. Then use those arrow keys in the top middle to move down to the bottom square. Open up your bracket, pop all of that in, close bracket and square it, press equals, and you will get that answer. Question 13. So to rotate a shape, we're going to use tracing paper. So take out some tracing paper and place it over the shape, making sure the tracing paper covers the 0, which is the centre you're swivelling around, and the shape itself, and draw around shape A on the tracing paper. And my little tip for you is do an arrow pointing upwards on the tracing paper to help you with the rotation. So go and put your pencil on 0 to act as a pivot. Now we're going 90 degrees clockwise, so move the tracing paper around until the arrow is pointing to the right. That will take the shape over here, so just press through the tracing paper, creating an indentation. Obviously remove the tracing paper and go over the indentation in pencil, and just double check, just repeat the exercise with tracing paper to make sure that you've got it correct. Now for part B, how do we get from B to C? Well, we're reflecting, it's a reflection in the y-axis. Question 14. Now remember, factorising means putting the brackets in. So we're going to take out the highest common factor outside the bracket. So what's the biggest number that goes into both 5 and 10? Well, that's 5. So take 5 outside the bracket. So we have 5 open bracket. 5 times what gives us 5? Well, that's a 1. Get the sign right, it's a minus. Then 5 times what gives us 10m? Well, that's 2m. And obviously it's easy to check your answer, just expand and we get 5 minus 10m. Now for part B, factorise fully, so focus on the word fully. This means there's going to be more than one component coming outside the bracket. So work your way across. What's the highest common factor of 2 and 6? Well, that's 2. What's the highest common factor of a squared and a? Well, that's a. What's the highest common factor of b and b squared? Well, that's b. So all three components come outside the bracket and open up your bracket. Then consider this first clause. 2ab times what gives you 2a squared b? Well, all we're missing is another a. Get the sign right. And then consider the second clause. 2ab times what gives us 6ab squared? Well, we need a 3 to get the 6, and we need another b. So 2ab times 3b gives us 6ab squared. Question 15. So, it's just possible to put this straight into your calculator. You could do 4.7 times 10 to the minus 1 and press the equals key. This will give you 47 over 100, and then just press the SD key and it will give you the answer of 0.47. But just in case this question was to crop up on a non-calculator paper, okay, so just think about what's going on. So it's times 10 to the minus power, so this means it's a small number. So write your 4.7 down and put some zeros to the left to jump over. We're just doing one hop to the left, so that gives us 0.47. Now for part B, just put this straight into your calculator, taking advantage of the times 10 to the x button right at the bottom in the middle of your calculator. Now that's going to give you this whole number, this real number here, okay, this ordinary number here. Now we need to give our answer in standard form. Now with standard form, remember the first component is always between 1 and 10. So where would we put our decimal point to get a number between 1 and 10? It will be between the 2's, giving us 2.28. Now make sure you still include the 2 and the 8. Don't drop any of the numbers. So our first component is 2.28 times 10 to the power of something. The power is always going to be positive now because this is a big number. So you now need to consider the number of hops. The decimal point for this ordinary number starts off at the end. It is here. And it has to end up between the 2's. So how many hops is that? 1, 2, 3, 4, 5, 6, 7, 8, 9 hops. So that's 2.28 times 10 to the power of 9. Question 16. Now T is 250 meters from point A. So it's anywhere from A, which is 250 meters away. So that's going to be a whole set of points which forming a circle away from A. Now 250 meters, given that we're saying 1 centimeter represents 100 meters, 250 meters is going to be 2.5 centimeters. Okay, 100 meters, 1 centimeter, 250 meters is 2.5 times as much, 2.5 centimeters. Okay, so T is going to be 250 meters from A. So we draw a circle 2.5 meters from A. Now we could draw the circle all the way around, but given that we're going to be finding that T is equidistant between B and C, it makes sense to just do that little arc, but by all means draw the whole of the circle if you wish. Now secondly, we're told that T is equidistant from point B and C. That means it's an equal distance from both B and C. So it could be here, that's equal distance from B and C, it could be here, it could be here, it could be here. So what we've got to do here, we've got to get the perpendicular bisector between B and C. That forms a line that is halfway between B and C and is perpendicular to the line between B and C. Now how do we draw a perpendicular bisector? We get our compass, we go and get put the point on the x at C and go and have a length which is most of the way towards B, and we draw an arc. We then repeat the exercise putting the point of the compass at B, clearly not changing the width of the arc. So don't change how far apart the pencil and the pin is on the compass. And we draw this second arc. So there in red are my two arcs from my compass. I then go and draw a line where the two arcs cross, between here and here, and that's the line I've drawn in green. Now point T is both those things. It is both on the purple line, the purple arc, and on the green line. So T must be where X marks the spot where those two cross. So that is one of the possible positions for T. Out of interest, the other possible position for T would be if I completed this circle all the way round, okay, where the green line went and crossed that circle again. So you could go and do that one if the paper that you were supplied with allowed. Question 17. Now the first thing we need to do is to work out the probability that the dice lands on a 1. Now probabilities add up to a whole. So if we go and add up all the other probabilities, so these 5 numbers here, we get 0.69. We go and take that away from 1, we go and get a 0.31. Now this question's talking about the number of times the dice will land on either a 1 or on a 3. On a 1 or on a 3. So we add these two probabilities together to get these two here, which gives us our 0.49. So with one single roll of the die, the chances of landing on either a 1 or a 3 is 0.49. Now given we go and roll it 200 times, an estimate for the total number of times we'll land on a 1 or a 3 is 200 multiplied by the 0.49, which is 98 times. Now question 18, there's a lot of information to disseminate here, so I find it quite useful just to set up a two-way table just to help me gather my thoughts. Not that on this occasion I needed to use that too much of it. So just to help me gather my thoughts, I've got the circle, the stalls in total, adults and children in total. And we're told that there are 117 children had seats in the circle, so that's where I've started off. Now, we know that 3/4 of the children had seats in the stalls. So the number of children who had seats in the stalls was 3 times as great as the number of children who had seats in the circle, because that's 1/4, this is 3/4. So 117 times by 3 gives me my 351. So how many children have I got in total? 117 and 351 is 468. Now I'm now going to focus on the fact that the ratio of the number of adults to the number of children was 5 to 2. So there's 2.5 times the number of adults. Okay, that's the adults, that's the children. 2 times 2.5 gives me the 5. Okay, so I've taken my 468 and I've multiplied it by 2.5 to get the number of adults. Alternatively, you could think of it as 468 children, that's the 2 shares. So divide that by 2 to get a single share, and then multiply that by 5 to get the number of adults. So 1170 adults, 468 children, add that together and that's a total number at the theatre of 1638. Now the theatre has a capacity of 2,600. Now 1638 divided by 2,600 is 63%. Now the question says, on this Saturday, were there people or more than 60% of the seat, or more than 60% of the seats? Well, yes, there was. We've just gone and shown that there were 63% of the seats being occupied. So yes, there were more than 60% of the seats being filled. There was 63% being filled. Question 19. So we're being asked to draw the front elevation and the side elevation. So we're told that this is the front of the shape. So the front elevation is just going to be that two-dimensional shape you see at the front. And then the side elevation is what you would see from the side. So that would comprise sort of this flat wall bit, if you like, and then this slanty roof. So we're told the scale is 2 centimeters to 1 meter. So to go from each of these meters to our grid scale, we're going to have to double each of the lengths. So our front elevation, when we go and draw this shape here, is going to have a base being 2 times 2, which is 4. Then a left-hand height of 2 lots of 2, which is 4 squares. A right-hand height of 2 lots of a half, which is 1, and then pop in the diagonal. Now for the side elevation, let's start off with the flat bit here first. So that's going to be doubling each of these 2 by 1, 2 squares by 1 square. But don't forget we've got this diagonal roof, okay? So if you were looking at it from the side, it wouldn't look like it had a flat roof. You would see this slanty bit, and the total height you would see would be 2 meters, which is 4 squares. And then don't forget to put in this horizontal line here to reflect the fact we're moving from a flat side surface to the slanty roof up here. Question 20. So let's just go and represent all this information on a little diagram. So we're going from Liverpool to Manchester to Sheffield. This is 56 kilometres, this is 61 kilometres, and this journey took 75 minutes. So we need to start off by working out in minutes how long it took to get from Liverpool to Manchester. Now we're travelling at 70 kilometres per hour. That means we go 70 kilometres in 60 minutes. So we need to use this proportion. 70 kilometres takes 60 minutes. So 56 kilometres is going to take how many minutes? Well, I've taken my 56, divided it by 70 and multiplied it by 60. Okay, or in other words, I've taken my 56, multiplied it by 60, divided by 70, the same thing. We end up with 48 minutes. So I now know the distance and time for each of the components of the journey. Okay, 3 of them were given to me, and I've just worked out this was 48 minutes. Now speed is distance over time, so our total distance is the 56 and 61 kilometres, and my total time in minutes is my 48 minutes that I've just worked out, and the 75 minutes given in the question. So in kilometres per minute, that's 117 divided by 123. Now I need to give my answers in kilometres per hour, so I'm going to go and convert 123 minutes into hours. Now be careful here, okay, because there's 60 minutes in an hour. This is 2 hours, okay, that's taking up 120 minutes. That leaves us with 3 minutes, okay, that's 3 minutes out of 60, so 3 over 60, that's the 20th. So 123 minutes is 2 1/20 hours. So our final answer is going to be 117 divided by 2 1/20, which is 57.07 kilometres per hour. Now for part B, we're being told that for part of the journey for Barnsley to Leeds, we're travelling at 80 kilometres per hour, and then secondly from Leeds to York at 60 kilometres per hour. Now, well, clearly this is only going to, the average is only going to be 70 if the time taken for both journeys was the same. Because clearly, if you're going at 100 miles per hour for an hour, and then you just go at 10 miles per hour for just a minute, then clearly you can't just average the two. So for this to work, the time taken for both parts of the journey must be the same. Question 21. Well, we've got similar triangles here, okay? Because these lines from A to E and B to D are parallel, we've got 2 similar triangles. We've got this bigger triangle from A to E to C, and this smaller triangle from B to D to C. So let's go and draw those 2 triangles next to each other and fill in all the measurements we know. Well, we know that from E to C is 8.1, D to C is 5.4, and D to B is 2.6. So the side we have in common is the base. We know the base is 8.1 for the bigger shape and 5.4 for the smaller shape. Now if we go and do 5.4 divided by 8.1, we can see that to go from the bigger to the smaller, we multiply by 2 over 3, okay, to make it smaller. Or if you like, you can think of it the other way. To go from the smaller to the bigger, you multiply by 3 over 2 or divide by 2 over 3. That's the same thing. Now we're being asked to work out the length of A to E. This is the bigger length here. So we take our 2.6 and multiply it by 3 over 2 or divide it by 2 over 3, and that gives us 3.9. Now for part B, we're told that the length from A to C is 6.15. So I just filled that in here, and we've got to work out the length from A to B. So to start off, we're going to work out what the length is from B to C. Okay, this shorter length here. So we take our 6.15 and we multiply that by 2/3 to get 4.1. So B to C is 4.1. A to C is 6.15, so A to B is the difference. So that's 6.15, take away 4.1, which is 2.05. Question 22. So, which bank will give an IL the most interest at the end of 3 years? So let's have a look at the personal bank first of all. So we've invested £25,000. Now, because the interest rate is 2%, that is a multiplier of 1.02. We've invested it for 3 years, so that's to the power of 3. So popping that into our calculator, we get £26,530.20. Now moving on to the secure bank. So we're still investing the £25,000. Now for the first year, the interest rate is 4.3. So that is a multiplier of 1.043, effectively to the power of 1, because that's just for 1 year. But then for the following 2 years, it's 0.9% for each of those 2 years. So 0.9% gives us a multiplier of 1.009. So be careful with that. Not 1.09, that would be 9%. So 1.009 is for each of the 2 extra years, so that's to the power of 2. Now popping that into our calculator, we get this. So we can see that Secure Bank just gives us the most interest. It's giving us about another £16 or so. Question 23. So our number n is rounded to 2 decimal places and we got 4.76. So 4.76. So to 2 decimal places, the next number up would be 4.77 and the next number down would be 4.75. Now we want to know which numbers on this number line round to 4.76. So we really go up to halfway as the boundary between 4.76 and 4.77. Numbers below that will round to 4.76. Above 4.765 will round up to 4.77. And similarly here, okay, what numbers round to 4.76? Well, it's going to be, the boundary is going to be halfway between the two, 4.755. Anything below that will round to 4.75 and above that will round to 4.76. So that's how we've got our 2 boundaries. Now what about the inequality sign? Now if it's exactly 4.755, we round upwards. So 4.755 is the value we want, because that does round up to 4.76. That's why we've included the equal sign on the inequality. However, at 4.765 exactly, that rounds up to 4.77. It doesn't round to our 4.76, so we don't want that value. That's why the second inequality sign doesn't have the equal sign. And remember how these inequality signs work. You read it from the middle. So this reads n being less than 4.765, but careful with this one here. This, you're reading it from the middle. This is n being greater than or equal to 4.755. Question 24. So we're going to start off by factorising the left-hand side. So what 2 magic numbers multiply to be the minus 24, but add to be the plus 5? That's what we've got to remember, right? Multiplies to be minus 24, adds to be the plus 5. So that's going to be a minus 3 and an 8, because minus 3 multiplied by 8 is minus 24, yet minus 3 add 8 is the plus 5. So those are our magic numbers. Okay. Now setting up our pair of brackets, the first term in each has to be an x, because the x times by the x gives us the x squared, and we've just worked out our magic numbers to be minus 3 and plus 8. Okay, so factorising this, we get x minus 3 and x plus 8 equaling 0. So this bracket times this bracket equals 0. Now 0 times anything equals 0, so we've got to think in turn what values of x makes each of these brackets 0. Now how do we make this first bracket 0? That is when x is 3, because when x is 3, 3 take away 3 is nothing, and nothing times whatever is 0. Then moving on to the second bracket, how do we make this bracket 0, that is when x is minus 8, because whatever times 0 is also 0. So our two solutions here are x equaling 3 and x being minus 8. And just note how your solutions are the magic numbers but with the signs reversed. Question 25. So for part A, this is an arithmetic sequence, so we've just got to work through the process for working out the nth term expression. So step 1, see how much you're going up by each time, and we're going up by 5s. So our first term is 5n. Had we been going up in 6s, it would have been 6n, and so on. Now we then have to do this little adjustment. Now this adjustment is what we call the 0th term. It's an imaginary number that would go in front of the first term. So there's the first term, there's the second term. What would be this 0th term? Now going right to left, we can see we're going down by 5s. So 3 take away 5 would give us minus 2. So our nth term expression is 5n minus 2. Now for part B, Nathan says the fourth term of the sequence is 144. So if it's the fourth term, that is when n equals 4. So we need to substitute 4 into this nth term expression and see what we got. Now following BIDMAS correctly, we've got to do the squaring first. 4 fours is 16, 16 times 3 is 48. So Nathan's got it wrong because he hasn't followed BIDMAS. He's done 3 fours are 12, then 12 squared. Okay, so Nathan is not right. The 4 is squared before the multiplication by 3. Something like that.